Hello everyone, welcome to my YouTube channel. I'm going to talk about hypothesis testing on NLP dataset. I'm using opinion lexicon dataset. Basically, this dataset is compiled by Hugh and Liu in 2004 as part of their research on sentiment analysis and opinion mining. This is available in NLTK corpus, and this is a collection of various text resources for natural language processing tasks. It has two files, two text files. One is positive words.txt and negative words.txt. So these two files are compiled from the review comments. Those reviews will have positive comments and negative comments. So they collected all these positive comments and the unique words from the positive comments, and they collected the negative comments and they collected the unique words from the negative comments too, and they kept it in a two separate files. The positive words.txt file has 2006 keywords with positive sentiments, and the negative words.txt file has approximately 4783 words with negative sentiments. So you can see the example of some of the positive words and some of the negative words here. I'm going to use this dataset to explain how we can perform hypothetical statistical test on this dataset. Okay, let me explain about the objective here. My objective here is to find whether the average length of the words, the positive review words and negative review words, are following the same kind of distribution. For that, I import NLTK module, import the dataset from NLTK corpus. NLTK download opinion lexicon. I downloaded this opinion lexicon dataset. Now I collect the positive review words. And also negative review words. If you want to look at the first set of words, let me print the first 10 words from the positive review words. So these are the first 10 words from the positive review words list, and negative review words. So these are the words from the negative review words set. Now let me find out the lengths of the words from the positive and review word sets. take the length of the word, and the same thing I use for negative review words also. If we print the positive review word lengths of the first 10 words, so these are the lengths of the first 10 words, and from the negative review words also, these are the lengths of the first 10 words. Now, I wanted to understand the average length of the positive review words and review words length and negative review words length. So print average length of positive review words. For that, I use NumPy module, import NumPy as NP. I will take np dot mean of positive review word length. For negative review words, okay, let me run this. So average length of the positive review words is 8.5179 and average length of negative review words is 8.357. Now I wanted to see the distribution also because the average length of the words is almost similar. Uh, I wanted to check the distribution, how the length of the words are distributed. For that, I use Seaborn module. I use KDE is equal to true. We see that these are the x-axis, it represents the word length, and y-axis represents the count. It seems like a normal distribution bell curve, but with some tail. And I can see that the distribution is not symmetric. Okay, the same I plot for negative review words also. Here there is a long tail compared to the positive review word set, and the spread of the curve is a bit different here, and the count also is different from here. But when we look at the both the plots, histogram plots, it seems like both may follow a normal distribution curve, a Gaussian distribution curve. So, but by looking at the histograms, we cannot say exactly both may follow a normal distribution or may not follow a normal distribution. We can prove this using a statistical test. I wanted to use a Shapiro test to prove that whether these distributions, length of the words distributions, are following a normal distribution or not. For that, I will import a SciPy module. Shapiro test, it returns the test statistic, comma p-value, the probability value. Shapiro of positive reviewers lens. And if the p-value is less than 5%, that is 0.05, then I print that the data is not normal, not following normal distribution. Else, I print that the data is following a normal distribution. Let me run this. The data is not following a normal distribution. When I looked at the positive review words lens, then the probability value is less than 5%. So it says that the data is not following a normal distribution. May it look like a normal distribution bell curve, but there are several parameters when we are performing a statistical test so that we can prove here this is not a normal distribution curve. And I wanted to check the same for the negative words lens. Let me run this. Okay, here also the negative reviewers lens also are not following the normal distribution curve. Okay, we understand that the whatever the distributions we have from positive review words and negative review words are not following a Gaussian distribution. So we need to test now that whether maybe those distributions are not following the normal distribution, but the distribution of the words in the positive words text and negative words text may be the same or may not be the same. So this statement we need to prove using hypothetical hypothesis test. In hypothesis test, the main thing you need to define first null hypothesis. What is the null hypothesis here? Null hypothesis is an assumption you have to made first. Your objective here is you need to understand that the positive review words distribution and negative review words distribution are significantly different or same. That is your objective to know. So you make an assumption that initially the assumption is the null hypothesis is the positive review words lens and the negative review words lens are following the same kind of distribution. Words and negative review words lens are following the same distribution and not significantly different. This is the null hypothesis statement. So using this, you are making a null hypothesis statement here. Now we need to prove that whether this null hypothesis, you need to accept this null hypothesis or reject the null hypothesis. For that, I wanted to use Mann-Whitney-U statistical test. Using this is a non-parametric statistical test where we can find the two distributions whether are following the same kind of distribution or they are significantly different. For that, I am importing from SciPy module Mann-Whitney-U statistical test. It returns a test statistic and p-value. I will pass the positive reviewers lens and negative reviewers lens. And alternative, I pass it as two-sided. Now I define the alpha. Alpha is the benchmark value I define as 5%. And if my p-value is less than alpha, then I will reject null hypothesis. What is meant by rejecting null hypothesis? That means that we are against the assumption what we made. The assumption is both the distributions, both the reviewer length distributions are following the same distribution and they are not significantly different. But if we say rejecting null hypothesis means both the distributions are significantly different. Else, accept null hypothesis, saying that both the distributions are following the same and there is no significant difference. I just copy the negative reviewers here. There may be a typo. Because of that, it is showing a red mark there. Here, it says that reject null hypothesis, both the distributions are significantly different. So here, the Mann-Whitney-U, this is a non-parametric test, statistical test. It says that it has conducted several, by taking several samples, the test was performed and ultimately it found out the probability value. The probability value is less than the benchmark value, that is 5%. And if it is the probability value is less than 5%, that means we need to reject the null hypothesis, reject the assumption statement. That means the both distributions are significantly different. Why? The reasons could be because of this tail, the outliers, and because of the spread of your data. The spread of your data is different in both the ways, and the skew and kurtosis values seems to be different between those two. So these are the parameters which may cause a different distributions. This hope this helps you to understand hypothetical hypothesis testing here. Thanks for watching.